problem 7.7, find the sets where the function f of x, the square root of x plus 2 times the arc cosine of x plus 2 is continuous and differentiable. Well, first of all, we need to find the domain of the function, right? Because this function is only defined in a domain, and so the sets where it's continuous and differentiable have to be subsets of the domain, right? So first, for the domain, we need that x plus 2 has to be greater or equal than 0, right? Because otherwise the square root is not defined. And the domain of the arc cosine is between -1 and 1. So x plus 2 is between -1 and 1. But x plus 2 has to be greater than 0, so that means combining these two conditions that the domain is these numbers. Okay, if we subtract 2 or -2 from both sides, we get this. So the domain of this function is -2, -1. Okay? Okay, so in this domain, now when is this function continuous? Well, we have that this function of two continuous functions, so f is continuous in its domain, okay? Because in this part, the two functions are continuous in their domain, okay? As for the derivative, well, we have to compute it and see where it is valid when it works, right? So now we have the derivative of the product is the derivative of the first element, which is 1 over 2 times the square root of this times this. So we have the arc cosine of x plus 2 divided by 2 times the square root of x plus 2, right? And then the derivative of x plus 2, which is 1. And then we have the derivative of the arc cosine is -1 over the square root of 1 minus, and in this case is x plus 2 squared, right? So we have minus and then times the square root of here, so we can write everything in the same square root, x plus 2, and then we have 1 minus x squared minus 4 minus 4x, or in other words, this is minus 3 minus 4x minus x squared, right? So in order for this function to be defined, well, this works because it's in the domain. This has to be different than 0, right? So x has to be different than -2. So f is not going to be differentiable in this point of the domain. And now in this case, not only this denominator has to be different than 0, but it also has to be positive, right? Because otherwise this square root is not defined. And this is the same as saying that x squared plus 4x plus 3 is negative. And if we factor this polynomial, we have x plus 1, x plus 3. You can find the roots easily, right? So this is a parabola that has two roots, one at -3 and the other one 1. So that means that it's going to be negative in this interval, okay? So x is going to be between -3 and -1, okay? So it overlaps with this interval, right? It has to be inside the domain, but without the point -1, okay? And without the point -2 because of this. So the function f is going to be differentiable in this interval, open interval, -1, -2.